Warm greetings to who are all listening this presentation. Today we are going to discuss about the heat treatment of metals. Myself J. Devinyanaraj, Assistant Professor Mechanical Engineering Department from Sethi Institute of Technology. This presentation contains heat treatment processes, heat treatment types and heat treatment applications. Heat treatment process. Heat treatment process nothing but process of changing the structure of metals by heating it to a predetermined temperature and holding it is temperature for a prescribed period of time and cooling it is a prescribed cooling rate. Here there is a criteria is a main important role acting in heat treatment process, that is a predetermined temperature and holding time and cooling rate. The combination of operations involves heating and cooling of metals in solid state to obtain desirable properties. The purpose of heat treatment process. There are four purposes of heat treatment process, that is a hardening and strengthening of metals, improve the machinability of metals, improve ductility and toughness of the metals, and improve wear and corrosion resistance of the metal. These are all the main purpose of the heat treatment process. Types of heat treatment process. The heat treatment process classified into four different types, that is annealing, normalizing, hardening and tempering. Annealing. This is a important heat treatment process on steel. The steels are heated for 30 to 50 degrees Celsius above the critical temperature at 7 to 3 degrees Celsius. The holding time for the annealing process is 30 to 60 minutes. The excessive heating causes coarse grain structure in the metal. The metal is cooled for after heating and holding with the furnace also. The cooling rate of this process is 150 degrees Celsius to 200 degrees Celsius per hour in the furnace. Types of annealing process. The annealing process is classified into 5 different types. That is, first one stress relief annealing, second one recrystallization annealing, third one steroidized annealing, fourth one full annealing, fifth one diffusion annealing or homogeneous annealing. First one stress relief annealing. It is used to removing the residual stresses on the metals. The steel heated below 500 degrees Celsius to 550 degrees Celsius below the recrystallization temperature at the rate of 600 degrees Celsius. The holding time of the stress relief annealing is 1 to 2 hours. The internal stress relieved without changing its microstructure. It is the main purpose of the stress release annealing. It is used for ferrous and non-ferrous alloys. Second one is a annealing process is process annealing. It is used to sheet and wire industries. The heating below the critical temperature around 600 degrees Celsius to 700 degrees Celsius. Holding it prolonged period and slow cooling. Broken up grains in the crystal lattice back into their normal. This is the process annealing processes. Increase the plasticity of the steel. It does not involve any phase change. Ferrite and cementite structure maintained throughout the process. Third annealing process is steroidized annealing. It is improved machinability. The hyper-eutected steel, perlite and cementite makes poor machinability. The tool is subjected to continuous shock load and poor surface finish. The heating above critical point, that is 600 degrees Celsius, prolonged heating occurs in the steroidized annealing, and cooling rate is 25 degrees Celsius to 35 degrees Celsius. It will completely break up the perlite and cementite network. Fourth one, full annealing. It is refines grains induced to softness, improve electrical and mechanical properties. This is the main purpose of the full annealing. The austenite by heating 15 degrees Celsius to 40 degrees Celsius above the critical temperature. Cooled with room temperature, it takes several time. The austenite decomposes as to form perlite and ferrite structure into hypoeutectile steels, and perlite and cementite structure becomes hypereutectile steels. Hardening. The second heat treatment process is hardening to produce high hardness of the steels. Hypoeutectile above upper critical temperature, that is a A3 line. The hypereutectile steels above lower critical temperature by A1 line, that is 30 degrees Celsius to 50 degrees Celsius. Hold this temperature and then quenching process occurs in the hardening process. After quenched, martensite structure is obtained. Martensite is a supersaturated solid solution of carbon in alpha ion components. It is very hard and brittle, and it imparts the high hardness structure. Next, homogeneous annealing. Heating at a high temperature on steel above 1100 degrees Celsius. It is prolonged holding time, takes 10 to 15 hours in this process. The cooling rate is 800 degrees Celsius to 850 degrees Celsius on furnace, in further cooling in the air also. After this process, metal becomes more uniform. In this process, coarse grain structure is obtained. Next one is a normalizing. It is increases in strength of a steel. Holding time is short period and cooling in atmospheric air. Hypoeutectile steel contains ferrite and perlite. After normalizing, changed into perlite and cementine structure. Quenching medium. Quenching medium is an important parameter in the hardening process. It is a heated metal object or kept in order to withdraw heat rapidly. Quenching medium in order to quenching speed as follows: caustic soda, brine solution, cold water, warm water, and mineral oil. Stages of quenching. There are three different stages of quenching occur in the quenching process. First one, vapor blanket cooling stage. Second one, vapor transport cooling stage. Third one, liquid cooling stage. Tempering. Reduce the internal stresses. After hardening process occurs, the tempering process takes place. Reduce the internal stresses and hardness. Increase the ductility and toughness. Harden steel and below critical point. Holding this temperature, prescribed time and slow cooled. Martensite and retained austenite decomposed into truecite and sorbate structure is formed. Stages of tempering. The first stage is 100 degrees Celsius to 200 degrees Celsius. In this stage, martensite is formed. The second stages of tempering is 200 degrees Celsius to 350 degrees Celsius. In this stage, transformation of retained austenites into bainite. Final stage. In this final stage, the temperature ranges between the 500 degrees Celsius to 600 degrees Celsius. Formation of sorbate structure in this stage. Types of tempering. Low temperature tempering. Second, medium temperature tempering. And third one is a high temperature tempering. These are the types of tempering. In low temperature tempering, it is applied in the carbon and tool steels. The temperature interval between the 150 degrees Celsius to 250 degrees Celsius. Purpose of the low temperature tempering is relieving the internal stress and increasing ductility without changing its structure. Medium temperature tempering. In the medium temperature tempering applied in the coil springs, hammers and chisels etc. The temperature interval between 350 degrees Celsius to 450 degrees Celsius. The martensite transformed into true-side structure in this medium temperature tempering. The purpose of the medium temperature tempering reduction in hardness and strength and increases in the elongation and ductility. The last one is a high temperature tempering. It is applied in the carbon and tool steels. The temperature interval between the 500 degrees Celsius to 650 degrees Celsius. Martensite transformed into sorbate structure. It is produced high ductility without loss in the hardness. It is applied in gear, shaft and connecting rod. Thank you.